Okay, YouTube, this is another example video of finding the vertex focus and directrix of some parabola given its equation here and then sketching its graph. And so we're going to start with the fact that what we have here is an equation of a parabola. We have a squared x but not a squared y, but that it's not in standard form. So just recalling that the standard form of a parabola here, if we want a vertically oriented parabola, we would have to have a squared x term. So we have this x minus h squared equal to 4 times p times y minus k to the first, or if we have a horizontally oriented parabola, then our standard form would be our y term squared, y minus k squared, equaling 4p times x minus the h value here, where our vertex, remember, is at h and k, so we have hk, and then p is the directed distance from the vertex to the focus. And so when we look at something like this here, this is an example that you'll see from time to time. We have this y equals negative 1/8 times this entire trinomial right here. And the first thing we're going to want to do is rewrite this so that it is in standard form. And so in terms of what kind of an orientation this must have, I would recognize that it does have a vertical orientation because it is our x variable that is the squared type of variable here. And so in order to write this in standard form, we get to, complete the square. And so just kind of the same thing we did in our last video here, except for one extra step that I want to mention here. If you have an equation where we want to write this in standard form, and you have kind of this leading scalar out in front of our entire trinomial here, the first thing I want to do here or accomplish here is to multiply both sides by the reciprocal here. Whoops. The reciprocal of negative 1/8, which is negative 8. And so if we were to take both sides of this equation times a negative 8, essentially what's going to happen is on the right side, those two things are going to cancel out because anything times its reciprocal is just 1, and what we get left with is this right here. And so the neat thing about this expression is that we can go ahead and start completing the square. And so in terms of completing the square, what we want to see is that we want to get a squared binomial here for our x terms. So the first thing I'm going to do is I'm going to boot our constant here, and what we end up with is negative 8y minus 33, I'll space this out a little bit more, is equal to x squared plus 2x plus now what we would prefer to have in here in order to make this right side a perfect square trinomial. So if we wanted this to be a perfect square trinomial on the right side, remember that we always take half the middle term and square it. So we say half of 2 is 1 and 1 squared is 1. We're going to go ahead and add 1 to both sides of this equation here. And so because we do this, we certainly get a perfect square trinomial on the right side that factors down into x here, and we'd say half of this middle 2 would be a positive 1, so x plus 1 times x plus 1 would be its factors here. And then on the left side, we can actually go ahead and combine these like terms here, so we get negative 8y minus 32 is equal to this. Now, one thing that I'm going to do, and this is just something that I have a preference on, I'm going to put my squared term on the left side just because I know that when I look at things in standard form, I'm always used to having my squared term over here, but it certainly doesn't matter. The one thing that I do want to mention is now that we've got our squared binomial, the only other thing we want to make sure that we get here is that in front of our y or our x here inside the second quantity here, in this case a y, we're going to want that to be a 1. So what we're going to do is we're going to factor out the LC on the right-hand side, And what this is going to do is nothing to the left-hand side. It's just going to make this be a 1y in here. Now, in terms of what we have left over, this here, negative 32 divided by negative 8 would be a positive 4. But this is pretty neat because look what we have here. We have the standard form of this equation. All we had to do was complete the square just a little bit here. And so we would say, well, the things we wanted to find were the vertex, the focus, and the directrix. In terms of what we know, we could say the vertex, let me fix this here, the vertex is always at h and k, excuse me. So hk, let's go ahead and start by writing our vertex here. The value of h always associated with x, and the value of k always associated with y. We say here's our 4p. So we say the vertex of this particular parabola must be at h negative 1 and k negative 4. And so I'm going to go ahead and put that on my grid right now. We're going to say negative 1 down 4. We would say here's our vertex point right here. This is negative 1, negative 4. Now in terms of which orientation this has, because we have a squared x term, and that's kind of what we're used to with parabolas in terms of learning them. We say vertically oriented parabolas have a squared x term. Then I know that this parabola either opens up or opens down. So at least at this point we could put in the axis of symmetry that runs through the vertex here. Okay. So now, from here, we would say, what else could we find? Well, we want to find where the focus is and where the directrix is. So the focus, remember that because we know that 4p has to be equal to -8 here, solving for p, what we end up with is this -2. And so what that's going to tell us is from the vertex, we're going to go on our axis of symmetry down 2. And down 2 because we had a -2 for our directed distance here. So if we started at -1 comma -4, this is now going to be -1 comma -4 minus 2 more. In other words, we're going to get -1 comma -6 here as our focus value. So this is our focus, this is our vertex right here. And while we're at it, because the focus is 2 units downward, we'll go 2 units upward here and we'll drop in our directrix right here that we want to label with an equation here. We'd say this is y equals, now I could write this using the formula -4 plus the p unit here, or we could just say that we recognize that this is y equals -2. So in terms of our focus, we learned that our focus was 2 units downward on the axis of symmetry, so -1, -6, and we learned that our directrix, pardon me, is a vertical line, so x equals a number, and it's at a x value of -1 here. So we say x equals -1. Oh, sorry, directrix. I was looking at this line right here. Directrix is this horizontal line that we already labeled. I was like, wait a minute. We have y equals -2 right here. Cheers.